can we have a more comprehensive understanding and view of this power station. Today, we're honored to have with us Mr. Huang, the chief engineer of this project. Hello, everyone. I am the engineer of this power station. My name is Huang Wenbo. So all systems of this power station have undergone modulations and is now ready to generate power. There are all kinds of power stations, like coal-fired power plants and wind power station and PV stations. But this looks nothing like the power stations that are familiar to us. It almost looks like a film set in Hollywood to us. This is what we call a concentrated color power station, or CSP station. It collects the solar power and then channel them through this steam engine in order to generate power, and also the excessive heat can be stored in molten salt so that it can realize a 24-hour non-stop continuous power generation. I've did some homework because there are several power stations like this in the United States and in Spain. But this is probably such a power station, first power station of this size in China, right? That is true. It has a capacity, installed capacity of about 100 megawatts, and this is the first power station of this capacity this big in China. This is actually your ordinary mirrors, but with a bigger reflection rate. And also, it has to remain stable in order to concentrate on the receiving tower over there. The light reflected through these mirrors are actually quite sharp. It's almost make it quite difficult to look at it directly. It has better reflection efficiency than the mirrors that you use at home. So will they move automatically on its own? It has two trackers through which it can realize self-adjustment. The tracking system at the center is also installed with a knuckle, which enables it to rotate with 360 degrees, following the movement of the sun. It's highly efficient and highly precise, to the precision of 0.03 millimeters. The wind is pretty strong here, so will the this kind of mirror stand the strong wind? It is special designed to withstand this kind of strong wind. Today we are actually facing a quite severe conditions, one of the most extreme weathers here, because we have very low temperature as well as strong wind. But despite such harsh condition, it can still reflect the sunlight. Beneath each mirror, you can see a small box here, which is actually the control center, a small computer here. You can input the statistics of the solar radiation on a daily basis. In this way, this mirror can adjust the angle so as to better reflect the sunlight into the receiving tower. This is the central control unit of this mirror. So it works like a robot, actually. Through the control of the robotic center, the sunlight can be effectively reflected into the receiving tower at the center. It is such a big array of mirrors. So how long does it take for us to construct? We have a production unit producing about 100 panels on a daily basis. And it only takes about 100 days to produce all of these panels. It is fully automatic. Each of the panel is about 3.3 square meters each. So how many mirrors are there? Altogether, the square meters accumulated to about 1.4 million square meters combined. We can compare them to a gigantic sunflower concentrating sunlight and reflecting them into a central point. It circles around the receiving tower. They circle around the receiving tower. So will this kind of lighting control be very complex? Yes, we have a central computing control system with a programmed control system. The programming process is difficult, but it's quite easy to operate once the programming is completed. This is the production unit of the panel. Each minute, it produces 2.4 panels of mirrors in average. We are still making some last panels of units. This whole production line works like a tunnel. All of the mirrors have to go through this production line to make sure that it's stable, it is precise, it is up to the standard, it can work as designed. And it should be able to bend to a certain angle so as to form this kind of mirror array. So different mirrors have different angles, right? Yes, they have to work better to concentrate light. So the surface of the mirror is curved to different degrees. But most of the production phase is automatically controlled, and this production line is fully automated. so as to make sure that the mirrors can be combined to form a very smooth concave mirrors. As you can see, here is a mirror undergoing this production line in order to form a certain curve at the surface. So this is naturally a concave mirror in order to reflect the sunlight better. From an investment perspective, the production fee of mirror accounts for 60% of the total investment of the power station. That is the lion's share of the investment. The mirrors have to be precise, and they have to have high reflection efficiency. The reflection rate is under strictly control. This unit works like a tunnel. Actually, you cannot see this the whole picture of the production because it's a relatively an enclosed space, and there are belts transmitting the panels inside. So currently, we cannot see what it looks like inside. About 90% of the mirrors are already in place. Only some of the mirrors at the central place are yet to be installed because we have to leave room for big trucks, cargo trucks. So we leave some room, but we are coming to a close of the installation of the panels. This is a very big space, and we need to take a car to go to the center of the power station. Otherwise, this would take us too long to walk. Our viewers are asking the usage of solar energy is quite common in our daily lives. For example, we have photovoltaic water heater, which is used in every household, in a lot of households, and we have a solar panel road lights. So what are the differences between the solar panel and solar energy of the common sense and what we are witnessing right now? And I think the most common use that you mentioned is PV, as well as solar thermal power. And what we are witnessing now is one kind of solar thermal power generation. We have low temperature, mid temperature, and high temperature. For household use, it's mostly low temperature, the roof solar water heater. But in power stations, it is a high temperature utilization with a degree as high as thousands of degrees. And a lot of the heat is installed in this molten salt in order to generate power 24/7. So there is a very wide usage of solar power, high temperature, mid temperature, and low temperature. Low temperature is used at household level, for example, water heater and small power generation facilities that you use at home with a temperature of about a couple of degrees Celsius, but in the power station that we're witnessing here have a very much higher temperature. In future, the usage of solar energy will be more widely applied in industry. For example, we can accumulate the heat and absorb that heat and to make use of them without much transformation processes. The transformation process will be further simplified. You can see that most of the panels are at the horizontal level. So are they taking a break? Yes. If the wind reached a certain degree, the panel will adjust themselves to horizontal level so as to avoid taking too much wind force. You can see that it almost looks like a glass or steel forest here. It can also reduce the force of the wind, serving as the functions of the forests. It can also reduce carbon dioxide by 35 tons on a yearly basis. Sorry, that's 3.4 million tons per year. I think, as we can see, there are 4 areas, 4 divisions, and now this is the central tower, the receiving tower. All of the mirrors are arranged in circles, focusing on this receiver. It is a heat absorbent device. It's a facility absorbing all of these sunlight and then transfer the heat into the molten salt and then restore them at the tank below. So when sun rises each morning, all of the panel will rotate itself to face the sun, absorbing, reflecting the sunlight into this tower to a single point. The mirror will adjust itself to different angles because they locate in different places, and they reflect the sunlight to a central black heat absorbers at the top of the tower. The focus will be adjusted on a daily basis because the angle of the sun differs from day to day. The mirrors will adjust itself to the sun angles and then reflect them to the water absorber at the top of the tower. Looks like a chimney. So despite the absorber at the top, we have a lot of control system below, a lot of computers below. And you can consider this the brain of a human being, and this is the neck, controlling and processing all kinds of information that went through the system. This is called the molten salt CSP station, so it restores the heat into molten salt. So were there any other kinds of CSP stations? Yes, we also have parabolic trough and Fresnel trough and dish CSP stations. The height of the solar power is about 260 meters high, and there is another tower in a foreign country of about 241 meters high. These are the two highest solar towers in the world. It is different with the traditional PV power generation, because PV would directly transfer sunlight and solar energy into power. But this, you have another step in the middle, because you first store the heat of the solar energy and then use the steam engine, the steam turbine, to transfer into power. So it's concentration, storage, and then power generation. Right now, we are working towards the central control unit. This is the receiving tower. You can see very big tanks. That is where the heat is stored, is restored. It is used for energy restoration, energy storage. This is the key to the stable supply of heat, and also the key for the continuous operation of the power plant. The molten salt is about 565 degrees Celsius. That is the most ideal most ideal temperature for storing heat. So it's of paramount importance to make sure that the temperatures stay that way. So how high would the temperature be if all of the mirrors are reflecting towards the receiving tower? It can be as high as about 1,000 degrees Celsius, but the floating of the molten salt can actually cool the temperature and lower the temperature to about 500 degrees Celsius. It looks like a storage for grains, or that is used in agricultural sector. Yes, but actually it is used for heat storage. At the exterior, right now we are doing some final restoration, some decorations. We have also we are also doing some insulation process at the outside. The temperature of this tank is actually quite stable. It is fluctuating within about 1 degree Celsius. Even if we go without sunlight for several days, the temperature will not be lowered. This tank is designed to restore about 30,000 tons of molten salt. the heat can be stored into molten salt, and the heat restored in it can sustain a continuous operation of the turbo engine for about 11 hours non-stop. Even when the sun goes down, it can still generate power. In the morning and in a day, we can generate power while continuing to restore more heat for night operations. Today, despite this poor solar condition, sunlight condition, we still can restore enough salt into this tank to sustain power generation. So this whole place is not so huge. The tower is quite high with a lot of supporting facilities. It's not very big structure, to be honest, because if you look at a coal-fired power plant, it will be much bigger than this. It will not use coal, right? Yes, it makes full use of the sunlight without any demand for coals, and it will nor would to generate CO2 emission. Here you can see that the turbine is working with the steam coming out of it. This is a power generation island or power generation unit that is quite similar to a coal-fired power plant using steam engines to generate power. So actually, at the front end of the system is different from traditional coal-fired power plant. Does not use coal, but when it comes to power generation, it is quite similar to traditional coal-fired power plant. It's fair to say that the source of the energy is different. For example, in the nuclear power plant, you use nuclear fuels, and in coal-fired power plant, you use coal. But here, you use solar energy as the source of the heat in order to put the turbine in operation. The source of the steam is different. Let's go inside to take a closer look. From 2 days ago, the turbines are running in full capacity and began to generate power. This is the turbine room. This steam turbine is the same with the ones in the traditional coal-fired power plant, and also water hydropower plant. So the advantage of this power plant is to provide electricity that is completely the same with the traditional coal-fired power plant. It is also controllable and dispatchable. Here you can see some insulation to make sure that the temperature stays stable. Now let's take a look at the control unit, controlling all of the system and the coordinations among the systems. And this is actually the brain of the whole power plant. This is the central control of this power station. We can control heat absorbing, light concentration, as well as power generation unit here. This big screen here can control through this. You can control the panels of the mirrors. As you can see here, you can have an aerial shot of the mirrors circling around the central tower. So what if you go without sunlight for 3, 4, 5 days in a row? If we experience cloudy days for several days in a row, we can lower the operation capacity. For example, the units can be running at about 20% of its installed capacity. And then we can also look at the weather report to decide what kind of capacity will the unit be running at. So instead of going full capacity, it can generate a relatively smaller amount of power, but can still be running for 24/7. This kind of dispatchable system is much more flexible even than the coal-fired power plant, because the heat is stored in the molten salt. If you remember, you can just take out you can just extract the heat when you need it. We choose this location because the temperature here is relatively stable and is very suitable for build a CSP station here. So how many days are there with the ideal condition to generate power? On a yearly basis, we can utilize about 3,000 hours, and so on each day we can have about 10 hours, right? So will the electricity generated be different from winter to summer? And we have just experienced the dawn of the winter, which is the day with the poorest sunlight condition here. And in summer, this condition will be much better. The capacity, operation capacity of the power station can be adjusted through different seasons, because today the sunlight condition is not so good, so it is more advisable for us to lower the running capacity to make sure sustained power generation and prepare for bigger capacities when the sunlight is more sufficient. think this is a quite comprehensive control center. It is the brain of the center controlling different systems and coordinate these systems together. Absorbing, concentration, and power generation, all of these systems have to work together in order to make sure the smooth operation of the station. Right now, this control system is most of the technologies are self-developed, domestic developed, and domestically produced. Most of the facilities are designed and constructed domestically. Today, we also have the honor to have another guest with us. Who will be with us in just a second. As you can see, the exterior temperature is quite low today. That's why we lowered the running capacity of the turbines. And we are also doing some testing here. We have already done testing of the turbines running in full capacity. That is about 3,000 rotation per minute. And we are also doing some other internal testing before we can fully incorporate and generate electricity to the grid. We have finished most of the modulations, and right now we are doing some final modulations on the grid. After the electricity is transferred on grid, that will mark the official operation of this running of the station. So we're waiting for the the command of the national grid. It is fair to say that all things is ready. We are waiting for the last order to incorporate this into the national grid. This is our other guest from the National Bureau of Energy, Mr. Zeng Shaojun. I come here especially to congratulate the complete of this power station. So what does it mean for us to have such a big CSP power plant? Honestly speaking, in China, CSP station is still at a pilot stage. So the significance of this station is to test whether it is applicable both in technologies as well as in commercial sense, in business sense. And we need to make sure that this model can be replicated, and can be scaled up. And that would be the biggest significance of such a project. So far, this is still a demonstrating project, a pilot project. It is at a very preliminary stage. For example, bioenergy and the wind energy, they started at a very early stage, but CSP is still at a preliminary stage. But it is developing very fast. The installed capacity globally is developing by a very fast speed. It is quite complex system, as you can see. It needs the coordination of various departments. That is true. This is quite a complex system. It needs cooperation and coordination across many disciplinaries. So we actually increase from some smaller size power plants of about 10 megawatts, and right now it's 100 megawatts. But with such an increase in capacity comes much bigger challenges in technologies, in coordinations, and in construction. CSP is different from wind PV because wind and PV require sunlight or wind to generate power, but CSP can realize the storation and delayed power generation. When I came here, I really thought about the significance of CSP to the energy mix of our country, because it is actually a new source for power generation. And second, this new energy can actually coordinate and promote the existing PV and wind power generation. In the future, each PV stations and wind power generation station can be supported by CSP to serve as a ramping facility. And because the power generation of CSP can be more effectively modulated and dispatchable. And the third significance is that CSP can also contribute to heating in winter, which is also an important challenge for us to tackle. It is has great potential, but we have to admit that the cost is still very high and rely heavily on national subsidies. That's why I say that this still is a pilot project, but I think it can do a lot for us to expand the scale in order to lower the cost. And according to the 13th five-year plan, the installed capacity of CSP will be further expanded. Currently, we have 20 pilot projects, and despite such a big capacity, it still lags behind with our solar energy. If the scope of CSP can be further expanded, it can upgrade our energy mix and substantially reduce energy consumption and emission. This is the direction we are going, and that is also the significance of such a pilot project. We have to make sure that the technologies can work, and also we can. It is economically possible. So today we take you through this newly accomplished power station. CSP power stations of 100 megawatts in capacity, and we look at the mirrors, the panels, the panel arrays, the tower, as well as the control unit here. I'm sure that you now understand more about power generation of CSP, and that will be the end for today's live broadcast, and we will still be doing some follow-up reports in later days. Please follow us to get the latest updates. Thank you.